creating and using stored procedures. All right, another database object to get familiar with. This time we have a very important one, stored procedures. And what stored procedures allow us to do is incorporate programming components into our database application. So you can think of a stored procedure as pretty much just that, just a little unit of transact SQL code that goes out and does a specific task and returns results or doesn't return results. Really, stored procedures are very, very flexible coding components, and really the sky's the limit as far as what we can do with them. So we're going to start out here with a look at our outline before getting in and learning how to create and use these things. First off, again, here we'll take an introduction to stored procedures. I'll just get you familiar with an overview here of what stored procedures are, the benefits of using stored procedures, and also architecturally how they work underneath the hood. We'll then get into some demos here, and I'll show you how to create all the different forms of stored procedures out there here in creating and using stored procedures. We'll learn how to create a basic stored procedure that uses just simply a query. We can store a query in there and have it return a result set back. We'll talk about how to use stored procedures that accept input parameters and work off those input parameters to do specific tasks, such as, again, return data. We'll talk about how to use stored procedures that return output parameters. So all the different forms of stored procedures here. We'll also talk about the different ways we can execute stored procedures. And at the end here, we'll take a big look at how to work with stored procedures. We'll do things like learn how to encrypt a stored procedure to keep the content of that stored procedure nice and safe and secure. We'll also take a look at how to do things such as recompile a stored procedure. We'll talk about why we would want to do that, and a couple of other things along the way. So let's start off here with an introduction to stored procedures, and I just want to get you familiar with an overview of everything stored procedures, and also take you through some of the benefits here of using stored procedures. And I also want to show you kind of how they work underneath the hood in SQL Server. So first off, again, what is a stored procedure? Well, just a reusable code component stored within the database that we can call ourselves here whenever we're testing them, or we can call them from client applications to return the data, or do whatever it's supposed to do. What do they contain? Well, of course, they're going to contain transact SQL code. Now, the difference here is stored procedures have the entire transact SQL library at its disposal, where views can only use DML statements, data manipulation statements. Stored procedures can use everything, DML and DDL statements, data definition language statements. So we're really not limited as to what we can do with stored procedures. You can pretty much use everything with very, very few exceptions. What else do they contain here? Logic. They contain logic. We can do decision branching within our stored procedures, make decisions, run one block of code if a certain condition is true, run another block if something else is true. We can do loops. We can have error handling in it. Again, the sky's the limit as far as what we can do in a stored procedure. Stored procedures, as I mentioned earlier, can accept input parameters and then work dynamically off of those input parameters, so they're great for things such as search engines. We can build a search engine in a stored procedure to accept a multitude of parameters, and based on the ands and the ors of those parameters, return data back. So most websites are driven off of these types of stored procedures that accept all these different parameters, work off of the data, and then return results. Also, as I mentioned earlier, we can return output parameters to our stored procedures. We'll talk about certain situations on when to use either of these, and I of course will do a demo on both of these and see how they work. Also, stored procedures can return multiple result sets, something, again, a view cannot do. 3 different types of stored procedures out there. We have user-defined, the most popular, the ones that we're going to actually be creating, and that's exactly what these are, stored procedures that, of course, we create. Extended stored procedures that in previous versions of SQL, extended stored procedures could only be built in C++. Now, we have the entire CLR, the Common Language Runtime, at our disposal because it's a .NET compliant, so we can actually create our own extended stored procedures in another language, in our favorite .NET programming language, and then import them in here. And we'll actually talk about how to do these types of CLR things in our video on managed code. And then, of course, we also have system stored procedures that are specific to SQL Server themselves, and we can even tap in and use these system stored procedures as well. All right, let's go over some benefits of using stored procedures, and there's tons and tons of benefits, but these are some of the major ones. Number one here, fast precompiled and stored in the database. They're very, very fast because they're stored in the database and precompiled, and I'll talk about that here more on this one when we get in here, and I'll show you how this works. They reduce network traffic, of course, because they're stored in the database, and when we want to call stored procedures, we just simply use the word execute followed by the name of the stored procedure and then maybe some parameters, if any. And that's all we're sending over to the database server. So rather than before where we're sending over an entire query or we're sending over an entire script to be processed, it's all stored on the database. So we just called the stored procedure. Everything else is done on the database server itself. Also here we can enhance and simplify security. Number one, on the enhanced side, if you've ever heard of SQL injection, SQL injection is a very, very nasty way of attacking a database server and the objects in it. Basically, uh, take a search engine on a website, for instance. If someone were to put a SQL statement inside of a search box and terminated the statement on either end, if you're not careful and people are using dynamic SQL, you can actually do some serious harm. A smart hacker, or just anybody that knows SQL very well, could easily destroy objects within your database using what are called SQL injection attacks. Well, using stored procedures, that isn't a problem because, again, parameters kind of really discourage that from happening, and we'll talk a little bit more on that here when we get into it. But really, that's one way of enhancing security is using stored procedures because that can't really happen. Also here, as far as simplifying security, we can actually just give permission to stored procedures like we do views. And then any user using the stored procedure that has permission to it does not need permission to the underlying objects referenced within the stored procedure. It all happens automatically. So we can greatly simplify security doing that as well. Another biggie here is modular programming can save us time and maintainability. And this goes back to it's stored in the database. So all of our developers can be using the same units of code rather than everyone maintaining their own version of the same query, right? And that just makes it easier to maintain. If updates go into this, we update one centralized block of code rather than everyone maintaining their own version of a code base. So a lot easier to do it this way. Also, of course, they can be encrypted. That goes along with enhanced security here. Really nice that we can encrypt and secure the definitions of our stored procedures. All right, let's take a quick look here at why stored procedures are so fast. Other than the fact that they're stored in the database here, they're also pre-compiled. And what this basically means here, let's say that we're the developer here, we're creating a stored procedure. Once we pop that into SQL Server and create our stored procedure, the first time that it's ran, SQL Server will generate an execution plan for that stored procedure and then store it in memory. And it'll sit in memory as long as SQL Server is running until it's either restarted or until, of course, we delete it or modify it or do anything specifically to the stored procedure itself. And we can recompile it ourselves, something we'll talk about here coming up. But basically how this works then is anytime any subsequent user comes and runs a stored procedure, SQL Server will always use the stored execution plan. And that's what we mean by pre-compiled. Now, a few other things happen in there too. SQL Server does what's called parameter sniffing on stored procedures. And basically, what that means is not only can SQL Server reuse execution plans, but it can actually reuse the values of your parameters if your stored procedure, of course, has parameters in them. So it can use those values if they're the same, which will, of course, only make things even faster, especially on stored procedures that, have the same parameters passed into them constantly. Now, you may not want this pre-compilation to happen every time. Say, for instance, that we have a stored procedure that accepts a bunch of parameters, all of them being text parameters or character data. And say we have a search engine that users can pretty much type in anything they want, and it'll search our entire database and bring back those results based on their character searches. And just for the sake of it, say that we have a very, very large database, big catalog that they can search through. And chances are that no two searches will be the same within the same day. So basically, those parameters coming in, the values will always be different. In this case, we may not want a pre-compiled stored procedure because we're just SQL Server. It'll take SQL Server an extra step to search its cache for that execution plan. So we can save SQL Server a step by saying, you know what, skip the whole compilation here. We want to do a recompile every single time. So basically, it'll automatically generate an execution plan every single time the stored procedure is executed. And again, in the end, that'll save a step because it doesn't have to search the cache to find an existing execution plan and also see if those parameter values are the same by doing the whole parameter sniffing thing. So we can save it a step here, and I'll show you how to do that. It's called using the with recompile option when we create our stored procedures. And there's another form of recompiling as well. Say that something changes within our table structure, say a column changes or a data type within a column changes, or say we add more indexes. Now, the first scenario, and any sort of schema change within our objects, SQL Server will automatically mark our stored procedure to recompile the next time SQL Server restarts. A new index, however, SQL Server does not tell it to recompile. So there's a situation where we would want to force a recompile to generate a new execution plan. In this case, we have a way to do that, and I'll show you how to do that as well. So two different forms of recompiling. One is, do we always want our stored procedure to recompile, or do we need to force recompilation here if something were to change? Alright, so that's pretty much stored procedures in a nutshell. Everything that they can do, the benefits of them, and how they work underneath the hood. Now let's take a look at how we can actually use stored procedures here. And I'm going to show you all the different forms of stored procedures and some pretty cool things that we can do with them. So let's head on into SQL Server Management Studio here by heading down to Start, up to Programs, over to SQL Server 2005, and right down to our SQL Server Management Studio here. As soon as this fires up, we're going to connect to our production database. We'll hit Connect. And I'm also going to open up a script here that I threw together on creating stored procedures. We'll also connect the script right up to our production database here, and we're going to work into our AdventureWorks database. This is where we're going to work in to show all the different things we can do with stored procedures. Now, the first thing we're going to do here is create a basic stored procedure, and I say basic because this is just simply a query with a stored procedure wrapped around it because we don't have any input parameters here. We're not using any options on our stored procedure. Very, very simple. Just this would be a great candidate actually for a stored procedure because it would speed it up dramatically because again, it would be stored in the database, run on the server, and the execution plan would be pre-compiled and cached for us inside a SQL Server. But to create a stored procedure here is simple. We just do a create procedure followed by the name of the procedure. Any parameters go after this, and also any options, and I'll show you here shortly how to use parameters and options. Anything after the as statement here is the actual body of the stored procedure, and of course this is where all the bulk of our transact SQL code and logic would be within a stored procedure. Now, you can do this in code, which is a preferred way to do it, and really the only way to create stored procedures. You can do it through the interface, and it'll kind of give you a head start here. Let me show you. We'll go down in the databases here into AdventureWorks. Your stored procedures are going to be inside of the Programmability tab. And right under there, we have a stored procedures node. And within here, you can see there's already a bunch of pre-made stored procedures in the AdventureWorks database. We're going to build onto this library and add a few more. Again, if you want to create a stored procedure, though, you can just simply right-click on the stored procedures node and choose new stored procedure. And what this will do is make a brand new query here, and it's just basically a template. And it's a very, very simple template, but it shows you here how to, add parameters in here and just kind of gives you a basic select statement. And also here, a very nice area to add comments in, author, create date, description, so on and so forth. If you want to actually use this as a template, you can go up to the query menu here and choose specify value for templates, and we can fill in all of these placeholders here. See, all of these are actually just placeholders for the procedure name, any parameters you want. So you can fill them in using a nice dialog box, and boom, you're off and running there with the stored procedure template. I like to just create them from scratch, just used to doing it that way, and eventually you will too, as stored procedures are very easy to use. It's really the bulk of the work is just writing your transact SQL code. So take a look at this stored procedure here. What we're doing is I actually ripped this out of our view video, and it just basically grabs all the bike sales broken out by year. I actually tweaked it a little bit here and put the year in here, and then we're grabbing the year, the total quantity, and the total sales for each product that is a bike here, where we have product subcategory ID equals 1. And then we group by the name of the bike, or the product, and also by the year here, and then we're also going to order it by that. So just to show you how this would look without a stored procedure, just highlighting the code and executing it. See, it takes a little bit to run there, and then we get the results. All of our bikes broken out by year, total quantity in that year, and total sales for that year. Now, if we were to make this a stored procedure here, let's just highlight all of this code and hit execute. There we go. Now it's a stored procedure, and if we right-click on our stored procedures node, choose refresh, there it is, sales.sp get yearly bike sales. Now, if we want to execute this stored procedure, a few things we can do here. We can just simply type in the name of the stored procedure. So I'm going to go ahead and highlight this, hit copy, and I'm going to paste it down here. There we go, and highlight it, and hit execute, and boom, there it is. And now that was the first time it was run, so it had to generate the execution plan and store it in SQL Server's memory there. So it was the first time it was ran, and that's one way to do it. Now, if you accept parameters, though, you're not going to be able to do it that way. You have to use the exec statement. So I just suggest getting familiar with using exec followed by the name of the stored procedure. And exec is, of course, short for execute, which you can spell it all out. It's just I prefer to use the short way, a little less typing here. Then we highlight it again, hit execute, and you can see it ran just a hair faster there. That's because it used the stored copy of our execution plan. And there we go. So there's a very basic stored procedure, really, just wrapped inside of, just a query wrapped inside of a stored procedure, and no parameters or anything, but you can see that's it. That's as easy it is to make a basic stored procedure. Let's move on here into a stored procedure that accepts input parameters, and of course we're going to take that same query here. Instead of being stuck to bikes here, why not just make this a parameter here on our category ID so we can get product sales rather than bike sales, right? And this is really where you're going to really start to see the power of stored procedures because we can begin parameterizing them and therefore making our queries a little more dynamic. So how we do this is first thing we need to do is declare our parameters. And this happens right after we name our stored procedure. So we have a create procedure followed by the name sales.sp get yearly product sales by ID. And it's followed, we just list them out here. So we can have a comma and then more parameters, comma, more parameters. You can see how it goes here. But basically, it has to start off with an ampersand followed by the name of the parameter. And this is how we're going to reference this value when it comes in inside of our code block down here. After you name your parameter, you have to give it a data type. What data type is this parameter coming in? And it's, of course, usually going to be the column that you're going to throw the parameter against. Of course, that's not always the case because you can convert and cast and all that good stuff, but generally speaking. So after we declare our parameter list here, we're all set. Now we can use it within our stored procedure. And you can see what we're doing here is we're just taking the product subcategory ID and we're assigning it into the value of our parameter, so where this column equals this parameter rather than above where we had a static value type in here, and 1 is, of course, our bikes category. So the difference here is a lot. Now, instead of just being tied to bikes, we can search for any product we want as long as we know the product ID. And, of course, if we were to tie this to a front end, that would be the front-end programmer's job to, of course, pass these IDs in based on what the user chooses within maybe a drop-down list of all the products. But let's go ahead and create this stored procedure. I'm just going to highlight it here and hit execute. There we are. Now if we refresh our node again over here, you can see we have sales.sp get yearly product sales by ID. So to execute this, same thing. We just do an exec followed by the name of our stored procedure. So we'll highlight that and paste it in here, followed by any parameter values. So since we only have one here, we can just simply type in the value of that parameter. Now if it's a string or a character data, you have to cover it with quotes. And if you have multiple parameters here, you just separate them by a comma, just like so. Now we only have one in here, so we can just simply do this. And executing this will be just like our first stored procedure here because we're passing in a 1 here, 1 are bikes, so we should get the same result as before, which we do. Now say we didn't want bikes, we wanted components, being bike components, and I know that's a product category ID of 2 here. So if we highlight that, hit execute, check it out. There are all of our components. And I believe 3 is clothing. There's all the different clothing out there. And then I believe 4 is accessories. And there we go. Handlebars and such. Pretty cool, though. Now we've taken that simple store procedure, parameterized it, and now we're not locked into just a specific category. We can search on any category within our database. So pretty cool stuff here. And that's, again, just having one input parameter here in a stored procedure. And I'll show you how we can do a little more with the execute statement here coming up now, because we have multiple parameters to choose from, so we have different ways that we can execute it. Not only do we have different parameters here, but I'm also going to show you here how to use defaults. And then we're going to go back up here and mess around with this stored procedure. I'll show you how to alter it to do some pretty cool things with it. So heading on down here to our next stored procedure that has 2 input parameters, here's how it works. We're creating one called human resources.sp get employees by name. So basically a little directory search on our employees. So maybe our human resources department has an easier time of finding employees by doing wildcard searches. And what we're doing here is we're adding defaults on, because as we did up here in our previous stored procedure, we just simply have a parameter. We don't have any defaults on it. So what would happen is if we executed this stored procedure without supplying a value, guess what? We're going to get an error because it's going to say, sorry, I expected a parameter and it wasn't supplied. So give me a parameter or don't execute me. Basically what that is saying. So supplying defaults helps us there because now we don't have to supply a value. It'll automatically get replaced with the default. So back to our stored procedure here. Let's go ahead and kind of go through this. We define our first parameter as first name, and then we're going to set that equal to, as the default here, a percentage sign. And a percentage sign is a wildcard character inside a SQL Server, which basically means everything. And then we have our second parameter here broken out by a comma called last name, same data type, a character data, varying character data with a length of 50, and this is also going to equal a wildcard. So what this basically means here is users can just simply execute our stored procedure without supplying any values, and they will get every single individual in our company, right? And if they can supply a value for one and not the other, you know, we can supply an M for first name, we'll get all the names that start with M, and that's it, no last name. So things like that, very cool wildcard. And how we use this here is we just simply do where the first name is like, and then our first name plus wildcard. So this way, if they do supply a value, it'll automatically, this wildcard will get appended to it. If they don't supply a value, it'll just be 2 wildcards, which is the same as 1, which is everything, right? So let's go ahead and execute this and test around with it a little bit here. We'll create our stored procedure. Just make sure that it got created over here. We'll right-click, choose refresh, and here it is, human resources.sp get employees by name. Now let's go ahead and execute this. We'll type in our exec here, followed by the name of our stored procedure, followed by a name. How about M's here? Let's see all of our M's first off. Without last name, we're not going to supply a last name at all here. So we'll highlight this, hit execute, check it out. All the first names here start with M. Doesn't matter what the last name is because we didn't supply it, which means it'll automatically be everything. And let's see, what else do we have in here? How about we also supply a second one? How about all the M's as the first name and all the S's that start as the last name here? We'll highlight that and hit execute. See, we have a handful of them. And basically how we can do this. Very simple to do this. Now, another way to execute this, if you say we wanted to supply the last name parameter without having to supply the first name, because here, what if we just wanted to supply the last name? Well, we can't really do that. Well, we can. There's a couple of ways we could do this. We could say default specifically here, and then hit execute, and that'll automatically use the default on it. That's one way to supply a default. But let's say we didn't even want to do that for whatever reason. We just want to supply a last name. Well, we'd have to do this, and we have to actually name our parameter and say last name equals S. Now we can execute, and look at that. So a few ways of executing these stored procedures, and this is just, you would do this if you want to have your own order of passing the parameters in. Otherwise, keep it at the same order here, and just separate them by commas. Again, if you want to specifically say use the default, then use the keyword default, and it'll get passed in for you. So pretty cool stuff. Lots of different ways of executing these stored procedures. Those are pretty much all the different forms of doing so. All right, so now that we know how to assign defaults to our parameters within our stored procedures, let's head on back up to our previous stored procedure we were working on, and let's extend the functionality of this one a bit. Let's say, for instance, that users want to not only just get specific product categories, basically all these aggregations for specific categories, but say they want to get it for all categories. And the only way to do this now is to execute this stored procedure, X number of times, X being the number of categories within our store. So, and of course, in this sense, we only have 4. So that would mean a user would have to execute this procedure 4 different times to see every single category's sales. Let's make this a little easier. We can do this by doing a few things here. First, assigning a default to our parameter, to our category ID parameter. We're going to say null is going to be our default. So basically what this means now is if users execute this stored procedure without supplying any parameters, it's going to come in as null. And now all we need to do is put functionality within our where clause down here in our parameter to get all those categories to say if this is null, then return all the categories. And the best way to do this is using a very powerful function called coalesce. And this coalesce function is just a very wonderful function, especially when you're doing search engines. A very powerful function. I can't say it enough times because it really is. And I suggest getting familiar with this because there's a lot of things you can do with this outside of what I'm just going to do here with it. And what I'm going to do is use this function to basically say if this is null, then just use whatever value is being supplied to it within the join here. And I'll show you what I mean by that. The coalesce function here accepts X number of parameters or N number of parameters in SQL terms, and that is you can supply as many as you want here, and basically it's going to take the first non-null value. So the first value out of this list that isn't null is what the coalesce function is going to use. So what we're going to do is just supply 2 parameters here. The first one is going to be, of course, a product category ID, meaning if someone does pass in a value, then use it. Otherwise, if they don't, we're just going to pass in the exact column that we're doing the where clause on, and what that's going to do is it's going to use whatever is in the current join. So basically, it's going to end up using them all. It's going to use every single one within that table, and that's it. So now all we need to do is put an alter on here, because the stored procedure already exists. We're just changing the definition, re-highlight it all, hit execute. There we go. Now we won't get an error if we just execute this without supplying any parameters. It'll automatically default to null, and the coalesce function will take care of the rest here. So let's highlight that, hit execute. Look at that. We didn't get null, and we didn't get just one product, our category here. We got them all. There we go. Every single product. So very powerful and very cool how we can extend the functionality and save again, on performance, because users will not have to execute this stored procedure 4 different times to get every product. Now they can just execute it without a parameter. So great way to do that. So that's many of the wonderful things we can do with input parameters. Let's head on down and talk about output parameters here. And I have a stored procedure here that we can use to display and use output parameters here. Very simple. It works pretty much the same exact way, other than we have to declare, first of all, our parameter is output. So any parameters that you want to send back to the user, make sure you tag them with the output keyword after the data type. And what this stored procedure is going to do here is we're going to get an employee year-to-date sales. And really what we're doing is we're just returning a single value, right? We're not returning an entire record set here or data set, but just a single value. We're going to accept an employee ID as an integer here, and then we're going to return back through this output parameter just the year-to-date sales for the specific employee. So how this works here is we need to actually fill up this output parameter within the body of our stored procedure, and that's what we're doing here. We're just using a select statement to assign to this output parameter the year-to-date sales of an employee based on that employee ID that is coming in. So let's go ahead and highlight this code and execute it. There we go. Once we're executed, now there's a little more work in executing this too, because we actually have to create a parameter and then pass that parameter into the stored procedure, because again, that's our output parameter, and then it's going to get filled up when the stored procedure is executed here, and then we can do things with that output parameter and use it. So here we're declaring that parameter that's coming out to us called employee year-to-date sales. It's a money, and of course these have to match here. The next thing we're going to do is we're going to execute that stored procedure, passing in our input parameter here, and here's an employee ID 268. I know that employee exists and has sales. It's a salesman employee. And then again, our second parameter here is going to be that output parameter that we're supplying inside of our stored procedure. And again, this also has to be tagged as output on the outside when you're calling it. So tag it on the inside, tag it on the outside as an output parameter. And then once this executes, we're going to use the print statement to print out the YTD sales for this employee is, and then we're going to convert that from money to a character data, so it'll play nicely here with our string, and then just output it as a print statement. So we're basically just going to print out the output parameter. And there it is, our employee year-to-date sales. So we made our stored procedure here. Let's just make sure that it got in here by right-clicking on our node, hitting refresh. There it is, sales.sp get employee year-to-date sales. Let's highlight all this code, hit execute, and there we go. Year-to-date sales for this employee is that amount of money. So basically what output parameters come down to, use output parameters when you want to return a single value. They're great for that. Anything more than that, you can pretty much just use your standard data sets and return data sets and record sets and such from stored procedures. But output parameters definitely do have their place in the world. I've come across many situations where they're useful. And here's a great situation just like this to be used for an output parameter. All right, let's learn how to work with stored procedures here. And the first thing I want to talk about is handling errors. Both handling custom errors that we can define within our stored procedures, and also just handling unexpected errors using two very, very handy Transact SQL coding constructs. The first one here is a statement called raise error, and this is what we're going to use to raise our own errors and send them back to the user. So users get very friendly error messages rather than very cryptic SQL Server error messages, which we're all very, very aware of. Basically how this works is very simple. You just use the raise error statement followed by your own custom error message, and then the severity of it and the state. And there's actually a whole list of severity ranges within Books Online that you can take a look at. Basically 1 through 10 is not very severe, very light error message. And then you also have the state here, and the state is just an arbitrary number that you can use yourself to define, what your own errors mean, basically, or the state of the specific error. Now, what we're doing with this stored procedure here is we're taking back into our get yearly product sales by ID. Let's say that we want users to be able to pass in nothing, but we don't want them to get that cryptic error message back from SQL Server saying something about supplying a parameter. Also here, let's say that we don't want them to actually grab all of the products, all the products in all the categories at once, because if we have 100 users all doing that at the same time, we could run the potential of crashing our server, because that's a lot of processing it has to do to grab all and aggregate all this data on all of our product categories. So what we're going to do here is the same thing. We're going to allow a default value to come in as null, and that will basically mean that they can execute the stored procedure without passing parameters. In other words, they wouldn't get that crazy error message from SQL Server. But we're going to check it this time. We're going to say if that parameter is null, then we're going to send them a nice friendly error message back saying, error, you must specify a product category. rather than something about this stored procedure is expecting this parameter, so on and so forth. So we're just going to go ahead and highlight this once again, hit execute. Now if we head on back up to our code up here and try to execute this without a parameter, check it out. We're going to get a nice friendly error message rather than the old SQL Server error message we got in the past. So that's one way to catch errors and raise custom error messages within your stored procedure. Use the raise error statement. Very easy statement to get the hang of. Also here we have a brand new way of trapping errors that are unexpected within SQL Server, and it's called the try-catch statement. Now, this is brand new within SQL Server 2005, and if you're familiar with any programming languages out there, specifically the .NET programming languages, then you'll already be familiar with the try-catch statement. Try-catch statement, very, very handy. I'm actually just going to show you how to do it just in code here in a script rather than inside of a stored procedure. But basically how this works is you have a begin try and an end try. And this is a statement that you're trying. In other words, you know something could go wrong here. It's a point that errors happen frequently. Or you know something is going to happen here and you just want to trap for it, catch it, and do something else. Works like this. Again, begin try, end try with what you're trying, and then directly after that, and it has to be directly after your try here, you have a begin catch and an end catch. So basically what this is saying is if anything bad inside of here happens, or unexpected happens, or something that you know is going to happen, an error is raised, what it'll do is it'll automatically run what's inside of your catch block. And you can use these guys here, these actual built-in functions here, to analyze the error itself that has been raised. So you have error line, error number, error message, error severity, and error state. And there are other ones as well that you can use. Check it out in books online. Look up try-catch and you'll see the whole list of them. But this is a really, a much more structured way of dealing with errors, and even unexpected errors, than in the past. You can now wrap everything in a begin try and then have a friendly error message inside of your begin and end catch here. And just to show you how this works, this stored procedure actually does not work here. So if I just execute it by itself, you can see that, could not find stored procedure. Now let's wrap all this inside of a try-catch just to show you how this works here. This will get caught since it doesn't exist. That error will get caught, and this catch statement will get ran, and we're just going to get all the output of what all these error objects provide to us, all these error functions provide to us. So I'll highlight this, hit execute, and you can see it comes back as a nice, as a table basically. We have the error line, the error number, the error message, severity, and the state of that error. So pretty cool, very easy to use the begin try, and it's very powerful. I suggest again getting familiar with this because now we can trap for even the unexpected errors. Alright, how do we encrypt stored procedures? Well, it's very simple to do the encryption. The thing to know about when encrypting stored procedures is once you encrypt it, there's really no way of getting back at that definition. There is one way of doing it, and that is you have to be on the dedicated administrator connection in order to view the encrypted version of your stored procedure. But generally speaking, you're not going to be able to get at that stored procedure. And the best way to do this is, of course, leave them encrypted, your sensitive stored procedures encrypted inside of the database, but make sure you have the definition of that in a script somewhere that's stored securely in a file on your server somewhere. And of course, SourceSafe would be a great place for that. And some of the later versions, the newest version of SourceSafe, of course, you can integrate with SQL Server 2005. So a great place to store all of your create scripts and such. But basically what we're doing here is, let's say that we have our human resources.sp get employees by name. This stored procedure, we could consider this sensitive because it hits a few of the human resources table and it has personal information relating to our employees. So this could be a sensitive stored procedures that we would want to keep secure within our database. So what we can do here is use the with encryption option. And basically all of your options here that you're going to use the with statement here following your last parameter declaration but before the as clause. And then boom, you're off and running here. So we can do with encryption. We can do this during an alter. You can do it during a create procedure, just as long as you have it again after your parameters but before your as. So with encryption, there it is. We hit execute. Now our stored procedure is encrypted, and you can actually see your stored procedures pretty simply here. I'm just going to refresh our stored procedure node here, and look at this. Can you tell which one is our encrypted one? Yeah, it's the one with the lock on it there. So now if we try to modify this, if you right click and choose modify, check it out. We can't do it. If you try to script it, create to, new query window, we're going to get just a bunch of, actually, if you don't get an error message, you'll get a bunch of jargon text up there. But here it is, error message just telling us that we cannot access this data because the text is encrypted. So not even ourselves, once we encrypt it, we can't get at the definition of that. That's how secure it is. So again, If you're going to do something like this, just remember to have the actual definition stored securely in a file somewhere. But that's all you need to do to encrypt a stored procedure is do the with encryption in the definition of your stored procedure, and you're off and running. All right, let's take a look here at recompiling. And again, there's two different flavors of recompiling. The first one that I'm going to show you here is the actual recompile option on the stored procedure. And again, we use this recompile option when we do not want an execution plan stored for this stored procedure inside of cache within the memory of SQL Server. And basically what this means is every time that the stored procedure is called, it'll get recompiled. It'll have a new execution plan generated on the spot and used on the spot, and it won't be stored at all. And the reason we would want to do this is for something, and this wouldn't be a good stored procedure to do with recompile on here because this product category ID, it's always going to be 1, 2, 3, or 4, right? And so chances are we'll have many, many searches that are the same as the previous search. So this would actually benefit from an execution plan stored in the cache. What would benefit from a recompile, though, is the one we just encrypted here, because again, users, our human resources users may be searching this directory all day long, and what are the chances that we're going to have two of the same search here since we're using character searching? Now, you could argue that, if there's a lot of wildcard searches throughout the day where they're just searching the entire directory and getting a listing, yeah, this would actually benefit from it. But on the flip side of that, there'll probably be a lot more searches by first name or last name than there would wildcards. So, with that being said, this would be a good candidate for a recompile. And you can see here, if you want, we can do it just a with recompile by itself, just like we did a with encryption. Or if we want to add two options on here, we can just add a comma and then recompile. So this stored procedure here will be both encrypted and it'll be recompiled every time it is ran. So if we hit execute here, boom. So again, great stored procedure for a recompile would be something like this where you're doing character data. This one, however, wouldn't be. I just kind of wanted to show you how it would look like by itself here using the with recompile option. So that's one flavor, having a stored procedure actually get recompiled every time it's run. The second flavor of this is really just forcing a recompile. So why would we want to force a recompile here? Well, automatically, again, table changes, schema changes, anything within this stored procedure here, if anything were to change underneath the hood, it would automatically be marked for recompilation, but it wouldn't be recompiled until SQL Server was restarted and then the stored procedure was ran for the first time. Another scenario for this would be, say, a new index was put on a table that these queries run against. Well, in that case, SQL Server doesn't mark the stored procedure for recompilation. So in that case, you would want to do a recompile. But both cases, we could use this stored procedure to force a recompile. And what that would do is mark it for a recompile for the next run. So SQL Server wouldn't have to get restarted if we do this. It would just mean the next run it would automatically recompile and restore that execution plan. So a couple of different uses for this. I just wanted to throw that out there that you can force recompiles on your stored procedures. And this, especially when new indexes come on, it's a good idea to do this because your stored procedures can immediately begin taking advantage of those new indexes. But this is all you do. Just exec sp_recompiled followed by the name of your stored procedures in parentheses here, or excuse me, in quotes here. So it's a text string being passed in. And that's it. You can see now this object is successfully marked for recompilation, and the next time it's ran here, the next time it's executed, I'm just going to highlight our stored procedure here and hit execute. Boom. So now it had a new execution plan stored for it. And that's that. All right, so in the CBT Nugget, we took a look at creating and using stored procedures. We started off there with just an overview of what stored procedures are, all the different benefits we gain from them, all the different flavors of them out there. And then we also took a look here at kind of how they work underneath the hood from when we create them as a developer to when the first time they're ran and then subsequent runs, and of course to get their execution plans cached. We then jumped right into a demo here and took a look at how to create basic stored procedures with input parameters using defaults. We also took a look at output parameters here, and then a couple of different options there on creating stored procedures such as encrypting and recompiling. So all the major points of stored procedures. I hope this has been informative for you, and I thank you for viewing.